Hello, everybody. Welcome back to Ground Analytics. And today we will be working on a beginner level project, data analysis project using Python. We will be using Python from beginning to the end. And the choice of data sets is an Amazon sales data set with quite a number of columns and a lot of information that can actually perform a beginner level project to an intermediate level project, meaning you can use it for data analysis, then go on to use it for machine learning, for artificial intelligence, for creating models and all of that. So, and from what we can see here, we have some columns that need some data cleaning, and we have a lot to do with this data set. But for today, we will be focusing on data cleaning, data analysis, basic statistics, data visualization, and of course, we'll be adding some business context to it. Okay, so without further ado, let's move on. Of environment that we will be using is the Google Colab environment. Why Google Colab, you may ask? Well, it doesn't run on your system resources. It runs on cloud resources, meaning Google allocates some resources for you to use the notebook. Two, it allows for collaboration with teams, real-time editing, real-time collaboration, anything you might want. And another thing to note is you don't necessarily need to use the Google Colab notebook. You can use um, you can use your Jupyter notebook, your PyCharm, you can use the Visual Studio Code. But the difference between the Jupyter notebook and all others with the Google Colab notebook is for Google Colab, you need to bring your data set into Google Drive or into the notebook environment. But for all others, you can access your files on your local computer. For Google Colab, you cannot access the files on your local computer. You would have to bring them into the Colab environment or the Google Drive. And I've already brought my data set, the one that we'll be using, the Amazon sales data set. I brought it into the Drive environment. It is right here. Amazon sales data sets. I brought it into the Drive environment. So, and let us access the Colab notebook. Now, there are two ways to access the Colab notebook. You can access it from your Drive by clicking on New, More, and you have Google Collaboratory. Or you can access it from your browser. I can do this. Google, just type in Google Colab, go to Welcome to Colab, and straight away it brings you here. Now, what you must note is you must have a Gmail account to do this. Okay. And obviously, you must have a Google Drive as well. So I'm just going to click on New Notebook. And it's going to bring a new notebook for me. And here it says connect. The moment we type in, we put our code in a new cell, it will connect when we attempt to run it. So the first thing we are going to do is we are going to rename this notebook, and I'm going to call it Amazon Data Analysis because this project is a data analysis project. I'm going to call it Amazon Data Analysis. And the next thing we are going to do is we're going to import the libraries for this project. So I'm going to do this, import libraries for projects. So what I've just done is I'm trying to give a description to each of my cells. And the first library I'm going to import is pandas for analysis, PD. I'm going to import NumPy as well as NP, and I'm going to import Matplotlib, lib.pyplot as PLT. I'm going to import Seaborn as SNS. And that's all we'll be needing for this project. So I'm just going to go over it to make sure that I have everything written correctly. Matplotlib, NumPy, Pandas, Seaborn. Yes, everything is fine. And I'm going to click on Run. The moment you click on Run, it starts connecting. And you see that it's connected right here. And it's already saving as well. So the next thing we are going to do is, in order for the Colab notebook, to access your drive, you need to mount the drive onto the Colab notebook. So that's what we're going to do. So the next thing is mount Google Drive. Google Drive. And in order to do that, you just do from google.colab. It's an interactive notebook and is intelligent. So when you type in certain things, it will tell you, it will make certain suggestions for you. Drive dot mount. And what we have here is you put in your quotes, and I'm going to /content /drive. And I'm going to run this. So it's going to request access to connect to my Google Drive, and I'm going to grant it access. And this is it, Grande Analytics, continue. And yes, it's going to ask me for access, and I'm going to click continue. Now, it may come up with some options. You wanted to access certain documents. So you tick whatever options, you tick whatever options you wanted to access. And now it's been mounted. So we have mounted at content/drive. The next thing we're going to do is we're going to bring our data set into, we are going to load our data set into the notebook. So I'm going to need another code cell. And here is load. Oh, sorry, not mount. Load the data set, or load the file, data set or file, whichever one you want to work with. And I'm going to load the file that we're going to use, that's the Amazon data set, into a variable called df. So df equals pd.read_csv. And once you open this bracket and you put in your double quotes, what is requesting for is the path to your file on the drive. And in order to do that, I'm going to click on this. You can see now that we have the drive loaded in the notebook environment. And we have this drive because we executed cell number 2. Without executing cell number 2, the only things you will find are the folder and the sample_data. But this drive has come as a result of executing cell 2. So I'm going to click on this because I want to look for the file in my drive. And this is my drive. And I have a list of everything that is in my drive here. So I'm just going to look for the file, and the file is Amazon sales data set. It is here, right here. Look at it here. So I'm just going to click on this, and I'm going to copy part. And I'm going to copy that part and paste it here. /content/drive/Amazon sales data set. So leave it as it is, because this is how you're going to locate. This is how the notebook will locate the file on your drive. So I'm going to run this cell. And that's it. We don't have any issues. That means the data set has been located on the drive and it's been loaded into a variable called df. So from now on, I'm just going to reference, if I have to access this data set, I'm going to reference df. Okay. So the next thing we are going to do is we are now going to check our data set to see what exactly is inside. And in order to do that, I'm going to do df.shape. Now, df.shape, what df.shape does is it shows the number of rows and columns in our data set. And I'm also going to do df.head. df.head is going to display, oh, sorry, that's going to be on the next line. df.head is going to display the first 5 rows of our data set. If I want to display more than that, I can just put the number I want to display here inside the brackets. I can put 10, I can put 20. What this means is it can accept, it's a parameter, so it can accept any value. I can put 20, I can put 30. So I'm just going to play this. And this is what we have here. Now, it's only df.head that has worked. And that's because for df.shape, I just put in df.shape. I didn't ask it to display anything. So if I wanted to display anything, I'm going to put print here. So print, And I'm going to put this in brackets, print df.shape. So let's run this again and look at it here. So it's printed it for us. Now we have the number of rows is 1,465, and we have 16 columns. And we also have a preview of our data set. So let me just add a column. Sorry, let me add a comment here that says preview the data sets. Okay, so and this is what we have. Now we can see our data set. Of course, we have work to do from what you can see here. We have 16 columns, and if you look at category, it's got a lot of things munched up into one column. And we've also got discounted price with a symbol. I believe this is Indian rupees, and we have comma also in the actual price column. And what this means is if we are going to if we are going to do some calculations, we may not be able to do those calculations because of this symbol and possibly because of this comma, because now it means that our data set, Python does not see the data set as numbers. It cannot read it as digits. It's just reading it as objects, as strings, because of the presence of these things that are here. So what we are going to see, what we are also going to do now is, in order to begin the data cleaning process, let us close this up so that we can have a wider view. In order to begin the data cleaning process, we are going to check the data types, and we are also going to check for null values. So that is the next thing we are going to do. Code. So I'm going to put out a comment here, check data types and null values. Why is this important? It's important because we want to validate our data set. You do not want a data set with false information. And data cleaning is a very important step for data analysis. So we've begun our data cleaning process, and we can actually add a cell up here with text that says data commence with, or commence with data cleaning here, or begin data cleaning. I think that would be a better grammar. Begin data cleaning process. So we can only begin data cleaning process, and that is it. And that's it. Just move to the next cell, and it does that for you. And you can only clean what you can see. So if you cannot see your data set, you can't clean it. We want to get rid of null values, and we also want to see the data types. And in order to see the data types, we are going to run df.info, df.info, and also you can put a parameter. It's a parameter, so it simply means you can decide to put a column name or something. Maybe you just want to check the data type for a particular column or something. And we are going to do df.isNull in order to check the null values parameter .sum. And what this does is we want to add, we don't want it to just display the columns with the nulls. We want to know the number of null values. So let's run this. We want to know the sum of the null values. And look at that. So df.info has given us that, not null, non-null, non-null, and then we have this is the column, this is the number of rows for each of those columns. These are our column names, the number of rows for each of the columns, and then it's telling us that this non-null means that these columns cannot accept null values. And then we have objects here. But if you look closely, the data type, which is our main focus here, the data type is the main focus in this information. You will notice that all of the columns are classed as objects, meaning it may be hard for us to perform calculations on these columns. So meaning we will also have to convert some of those columns to numbers. Okay? So if on closer inspection, you will notice that For all the rows, rating count has 1,463, meaning it does have some null values. So we are going to come down here and check what this particular one has given us. df.isNull.sum, meaning that it should sum up the number of null values for each column. And we can see here that rating underscore count has 2 null values. Without doing this, without calculating this, you may not notice that you have null values here with just the df.info. So you may not notice you have null values with just df.info. But because you put the df.isNull.sum, you are able to pick that a particular column has 2 null values. So the next thing we are going to do, now that we understand that we have a column that has some null values, the next thing we are going to do is we are going to go on to clean our data set. Now, the first column that we want to clean, we're going to clean them one after the other. The first column that we want to clean is, let's do the numbers out of the way. So let's clean the price column. Let's clean our price column. Let's deal with the numbers first. Let's clean the price column. And so we're going to come here, open another code, and we're going to clean the price columns. And we don't have just one price columns. We have actual and discounted price columns. And in order to do that, the first thing we are going to do is we are going to define a function to clean these columns. And the reason we are defining a function is because we are cleaning more than just one column. You see, it's already giving us some suggestions. We are cleaning more than just one column. We are cleaning the actual price column and we are cleaning the discounted price column. So we are going to create a function that we can apply to both. And just in case you have more than 2 columns to clean, it's always safer to create a function. So in order to create a function, we are going to use define, and we're going to call our function clean underscore price. And we're going to, because it's a variable, we are going to make it a parameter. So we are going to put column in here. And what that simply means is that we can slot in a column name if we want. And then we put our semicolon. And you can notice this indent, and that's because it has recognized that this is a function and that we are trying to define a function. So return df, this is what we wanted to return when we apply this. Now this phase is for us to define what the function will do. And it's already giving us some suggestions. And it says df column, and that then we close that. Dot string, it already knows that we want to replace something, replace. And for our symbol, I can't find the Indian rupees on my dashboard, or sorry, on my keyboard. So I'm just going to come and copy it. It's a hard one. Copy it, or just go on the internet and type Indian rupees and just put it. And I'm going to put it in double quotes. And because I want it to return nothing, so I'm just going to put an empty quote string, an empty quote, and that's it. So the next thing is I also want it to replace wherever it finds comma. Remember that the dot replace, remember that the comma is the comma makes that equation to be considered as makes the column to be considered as a string. And so I'm going to make it as type float. As type float, meaning it can accept decimal and normal digits and all numbers. So this is it. I've just defined the function. So now that I've defined the function, I am going to apply the function to my discounted price column and the actual price column. And in order to do that, it's going to be, because it's another line, df, because if I continue on the indented line, it tells Python that I'm still defining the function, but I'm done defining the function. So it's going to be df, and I'm going to open, df is still our data, is still the variable that houses the data set. So df discounted price, which is the column, sorry, discounted underscore price, which is the name of the column, equals clean underscore price. That's the name here. Yes, clean underscore price, discounted price underscore price. Right. So that's the first, that's the first column it's going to clean. And the second one is going to clean is DF. This time is going to be actual price, column, sorry, quotes. I'm always calling that column, actual price, suggestion equals clean underscore price. Apply my function so that it can clean it. Actual price, actual underscore price. And there we go. So what I've said now is it should take this function that I've defined and the column that I've specified in this function. It should take it should take this column, the whole discounted price column, and apply this equation to it and store it in a new column and store it in a column called discounted price in the DF, in the data set. So DF already is the variable that houses our data set. So what this equation here does, this particular one, what this equation here does is this. It's going to apply this function that has been defined here to the discounted price column and the actual price column in the data set. It will now take the result and store it in this, again, in this particular column, again, that is defined in this data set. So it's just doing a replacement, but this time it's replacing with new values. Okay, so we are going to run this. And yes, it's worked. We do not have any issues. We can view it to see what, so we can run a df.add just to see the results. And if you run a df.head, you can see that now it's converted it to float. It has a decimal in it. There is no more comma and the Indian rupees are gone. So that is the phase one of this cleaning. Let's move on to phase two. So for phase two of the cleaning, or for the next cleaning measure, we are going to clean our rating count column and we will convert it to floats. So so that's what I'm going to do here. Now clean the rating underscore count column. And convert it to float. So what is wrong with the rating underscore count column? Okay, let's use this one. See that we have to take out the comma. We have to take out the comma and convert it to float. Okay, that is what we are going to do. So for this one, we don't need to define a function. We do not need to define a function because it is just one column, right? So what we are going to do is simple. df rating underscore count, yes, and equals to df rating underscore count, double quote, rating underscore count, dot string, dot replace, open bracket. What do we want to replace? We want to replace the comma. We want to replace it by nothingness. And then we want to change it to float. So dot as type float. Because it's a parameter, it accepts that parameter. And we are going to run this. And yes, so we can run another df.head here. It's always very good to check your results as you go on and not just to run things along. Let's see if it's worked and look at that. See our rating underscore count, and it is good to go for rating underscore count. Now, do we need to convert rating? No, rating is already in float, so rating is fine. So but in order to be sure, because this is just the appearance, we may want to just, convert the rating to float as well. Okay? Because we can only see a view of it. We can't see the whole thing. So in order to convert rating to float is almost the same thing. And this time around, it's going to be rating equals to, and that will be DF. Since we are just converting it to float, we won't need to, and we are not taking out any measures, or we are not taking out anything. The next thing, what we can do is we just do pandas. We use the pandas library, and pd dot to underscore numeric is already giving us the suggestion. And here we have df, sorry, not dr, df. Open your brackets, and that will be rating. Yes, rating. And the next thing we'll do is errors equals to coerce. And the reason for putting errors equals to coerce is if you it's just telling Python that if you meet anything that is not that cannot be converted, just convert it to none. None means NaN. It simply means it is not a numeric value. So it just means if it meets anything that it cannot convert to the value that is specified here to numeric, you should just leave it as none. And none will also help us to carry out our numeric calculations. It will not affect the numeric calculations. That's it basically. So the next thing we are going to do now is, and the last cleaning we are going to do now is we are going to split the category column, okay? So we are going to split our category column, and I'm going to do this, split the category column. And in order to do that, let's have a look at our category column first of all. Let's see the need. Now, we do not want to have, we want to be able to carry out detailed analysis. So we do not want to have a lot of repetitive things here. And trust me, this column is actually long. Let's look at it from here. Look at the column here. This is the category column. Where is it now? This is the category column. And let me try to stretch it. This is where you have 1, 2, 3, 4, 5. And then you have things changing, things repeating from one column to from one face after this slash to the other. So we are going to clean up our categories column. In order to do that, we are going to split the category column into, for now, we can split it into 3. You can decide to split it into 4, into 5. That is totally up to you. So we are going to split our original category column into 3 different columns. So what we are going to do is this: categories. The name of the column is category. So we are going to start by saying categories. We are going to create a variable, and that variable is going to have this this equation that will be performed on the category column. On that, and that will be category, and the next thing to do will be category dot string dot split. So we are splitting this, and we are going to tell you what we want to split it by. We want to split it by the slash. So column, and that slash, I have to look for this on my keyboard. Yes. And we are going to replace it. We are going to tell it if it should expand or not. So expand equals to true. Meaning we're expanding the column by this slash. Wherever this slash is found, it's going to be a new column. That's what it means. So then we are going to go df double category dot. We are going to, in this place, we are going to specify the number of categories that we want to put. the number of categories that we need, and the names of those categories. So we are going to specify the number of categories by their names. Category, I want to use category underscore main as the first one. My second will be category underscore sub one. That is what I want to call it, underscore sub one. And my next will be category underscore sub two. Oh, sorry, I need to put the quote. Category underscore sub two. And that's it. So I've just specified the names of the categories that I want. And then what I'm going to do now is I'm going to do an equals to, and I am going to tell it that these are the number of categories that I want. These are the number of positions that I want. So that is what this is for. Categories dot that's location actually, and I'm going to specify. It's already calculated it by the names that I gave it, that is going to be 3. So this simply means it should take only the first 3 split parts, which I've already defined in the categories, meaning it should take only the first 3 that I've defined, 1, 2, 3. It should create 3 new columns for only the first 3 after each slash. Remember, we have 5. If you go to the original data set, you will notice that there are 5 partitions using the slash. But I just want to take the first 3 occurrences, and that is what I've specified here. First 3 occurrences. Okay. So the next thing we are going to do now is we are going to continue with the we have not yet finished. Now, this code, what this code does is it takes each occurrence of this and splits it, and it takes only the first 3 and puts them into 3 new columns named category underscore main, category underscore sub, category underscore sub 2. Now, when I run this, it will give me that, but I'm going to have 4 columns. The 4 columns I'm going to have are the old category column that has all of those categories in them, and the 3 new category columns, namely category name, category underscore name, category underscore sub 1, and category underscore sub 2. But I do not want to have the main column. I want the main column to be taken off so that I'll have only these 3 new columns. So in order to do that, I'm going to do df.drop columns equals, isn't this just cool? Category, and it already knows what I want, which is the old column, basically. And I'm going to follow his prompt and say, okay, yes, I have to, because I want to specify other things, I have to use this. Yeah. So I'm just going to correct that. Take this off. And in place equals true. So yeah. And then I want it to display it. Have I closed it? Have I opened and closed all of it? Okay, I didn't close this. I need to close that. And this needs to go. This is wrong. Yes, so this is right. So df dot head. And I'm going to run this. Yes. So where's the old, let's check for the old category column is gone. Let's check for the new columns that we created. So now we have it here. Sorry. Now we have it here, category underscore main, category underscore sub 1, category underscore sub 2. And this is going to make analysis easy for us. So the next thing we are going to do now is we are going to do our exploratory data analysis. So I actually mistakenly clicked on view recommended plots, and you can see here, it's giving some really nice plots. Anyway, this is part of it. So you can also work with something like this to make your own project dynamic. Remember, this is the template, so you can make of it whatever you want. You see, it's already giving us some suggestions: rating versus rating count, discounted underscore price, actual price, rating. So there's a lot to work with here, but we are going to leave this part and we are going to move along the project. So that happened because I mistakenly clicked on view recommended plots. But this is something you can do. It doesn't have to be a mistake on your part. You can actually click on that and have fun while doing this. So the next thing we are going to do is click on code and, okay, not code. Let's use text instead. And text is begin exploratory data analysis. Okay. Yes. So we move to the code line. And the first thing we want to do is we want to carry out some basic statistics. So basic statistics. And for the basic statistics, we are going to be looking at df.describe. When you type, it's so intelligent that when you type some certain things, it just gives you some suggestions. And let's look at that. Our data frame, our new data set. Okay, runtime disconnected, runtime has been connected. Okay. I think it's because this is still running, and so I'm just going to close that up so that it doesn't disturb our session. Yes, so it doesn't disturb the session. And this is it. So with each of these, you have suggestions for charts, suggestions for you can convert it to a data frame. It can suggest charts for you that will make your reports dynamic, make your project dynamic. So you can make use of these resources. This is what makes the Google Colab environment really cool. You can make use of these resources to elaborate on your analysis. And the next thing we are going to do now is we've done our basic statistics. You can go on to explain what you think that this means, do a little bit of report on it. You can explore the charts and, talk on the charts, which will make your report dynamic. So the next thing is we're going to input another code. And this time around, what we want to do is we want to display the top 10 most expensive products. Yes, that's the next place. Display the top 10 most expensive products. So I'm going to comment that here, display the top 10 most expensive products, right? Most expensive products or most expensive category. It depends on you, but I'll be going with products for this one. And in order to do that, if you want to display the top 10 most expensive products, you have to use something called sort values. And we are going to need the actual price to know which of our products are expensive. It's already giving us a suggestion. So let us work with that. df.sort underscore values. Yes. And now the problem is we do not want to use the discounted price. We want to use the actual price. So I'm going to write in my own code. I'm not going to follow what it's saying to me. Actual underscore price. That's what I want to do. And I'm going to put a comma. Ascending equals false. Ascending is false because I want it in descending order, meaning from the most expensive to the least expensive. And I don't just want it to just display values for me. I also want it to display the name of the product, the category, and actually the price of the product. So in order to do that, I'm going to open my square brackets, and I'm going to open another square brackets as well. And I'm going to specify in this square brackets the columns that I want. Product underscore name. Let me check the columns that we are going to pick. I know I have product underscore name. So we are going to work with product underscore name. Product underscore name. We are going to display the category underscore main, and we are going to display the actual price. So let me see how category underscore main is written. Okay. Product underscore name, category underscore main, underscore main. And the next will be, oh no, let me close it here. And the next is the actual price, actual underscore price. No, I don't want discount percentage. And I'm going to close this. I'm going to close this and I'm going to head it, dot head. So display. And this is what we have. We have the top 10 products. And you can get a chart. Feel free to play with these charts, okay? Because they can reveal more information about your data set. And here we have the actual price. So we know, look at this. The most expensive products come from a dominant category, which is the electronics category. And that's very interesting. Now, the next thing we are going to calculate is we are going to calculate the best-selling category. The best-selling category. And this is going to let us know if the most expensive category is actually the best-selling category. So let us try that out. Display. Now, what do we do? That okay, calculate the best-selling category. Best underscore selling. Oh, it doesn't even need to be that. Best-selling category. So we are going to calculate and display the best-selling category. And the reason I use calculate is because we are going to, in order to get the best-selling category, we have to add the prices, right? We need to add the prices in order to get the best-selling category. We need to add the prices, right? And in this one, you can use discounted price if you want. We are going to use the actual price for this, okay? So the first line in our code to calculate the best-selling category is we need to create a variable, and we're going to call it category underscore sum. Category underscore sum equals to df dot group by. We have to use the group by, and we're using the group by because it's a sum calculation and it needs to group it by category. So now that we've said df dot group by, we have to specify the column that is going to group the equation by, which is category underscore main. The next thing we are going to do is we're going to specify the column that is going to carry the calculation, which is actual price. Actual underscore price, not rice. Let me bring this up a bit. Actual underscore price. And with that, we are going to do a dot sum, which is a calculation, open, close bracket, yes, dot sort, dot sum, dot sort. And the sort we are going to be using here is sort values and ascending false. And the next thing we are going to do is, now this is the calculation for, this is the calculation needed to get the best-selling category. Now, remember that we also want to display it. And in order to display it, we are going to plot it, basically. And in order to plot it, we are going to create another variable and just do category underscore sum dot plot. Okay, the plot. And here, now you don't necessarily need to know everything here because it's going to suggest it to you, and that's because it's intelligent, so you don't necessarily. And besides, when you keep working with these things over and over again, you know what exactly to put in the values. Fixed size for my bar chart, for this I think I'm going to prefer 10 and 6. You can always adjust it to fit. It's something you just play with, to be honest. 10, 6, and then I want the color of my bar chart to be green. Yes, why not? And so I've specified for what I want the bar chart to look like. Now, plot title. Plot title is simply what title do I want to give to my plot, and it suggested something to me. It's saying, okay, best selling category. I'm going to go with best selling category. It's a very intelligent tool. So it just looks at whatever it is you've typed at first, and it just keeps giving you suggestions. So for my X label, for plot X label, I want to label it as category. And then for my plot Y label, plt.y label, I want to label it as, should I do total sum? Let me do revenue instead. Let me just follow its lead. And one thing I also want is I want my plot to show. So plot.show. So, no, omitted one. And yeah, so here we are. We've written everything, virtually everything that we need for this equation, and let's run it. Fingers crossed we won't have an error. Okay, there's no error. That's good. And look at that. The best-selling category is the electronics category here. This is the best-selling category, followed by home and kitchen, and followed by computer accessories. See that? And of course, the most it is also the category with the most expensive products. So why not? I mean, why not? That's why it's the best-selling category. It has the most expensive products. What if we were to run it by discounted price? Do we check discounted price and see if it will still be the best selling discounted? And then let me run that. Even with discounted price, it is still electronics. So electronics is actually a very, very strong category. So I'll change this back to actual price. Of course, you can go on to do the least selling category. If it's the least selling category, all you just need to do is to change ascending to true. So it gives you the least selling category. Let's try that out. Ascending equals to true, and let's see if we get if we get the least selling category. That would be the least selling category. Toys and games are the least selling category, and we can't even find the figure. So I'll change this back to the original. I'm just playing with it at this point. And yeah, and I encourage you to do the same to make your report dynamic, so we don't have one of the same thing all over the internet. Okay. Yeah, and you can change yours to from green to red to blue. It's totally up to you. So the next thing we are going to do is um, let's determine the best rated category. Yes, let's do something on ratings. So let's do the best rated category. The best rated category. So for the best rated category, we are going to start with a variable, and we're going to call it category underscore rating, and equals to, of course, it's based on what we did before. It's already suggested some things to us. So df.group by, and this time around, since it's the best rated category, category underscore main. Yes, and that, and of course, we are also going to use the we've done our df.group by. We are also going to specify the we're going to specify the column, and because it is best rated category, we are calculating the average, not the sum. We cannot add it. We are calculating the average, okay? And we are using rating. And if you come up here, let's look at what the values look like in our rating column. What do the values look like? So this is the written column. We have 4.2, 4.0, 3.9. So obviously we are going to calculate the average. So we have category underscore main, we have rating, and the next thing we are going to do, because it's average, we don't have average here. What we are going to use is mean. So mean, we use mean, and then it's giving us other suggestion dot sort, and it's going to be sort values. It's the best rated, so ascending is going to be what? Ascending will be false, so that it gives us in descending. Okay? And again, we want to plot it, we want to replot it, we want it to show. So you don't need to stress yourself or anything. It's already giving you something here. It says, let's go to the next. Okay, category. It knows that we want to plot it. Category underscore rating. So you can just click on accept. There's an accept here because what it has done is it took your old code. It now knows what you want, and it has fixed in the things that you would like to see. So you can always edit it. So I'm just going to do accept. If it's going to, okay, accept that. And I'm going to do accept here. And look at that, best rated category. Let me put it here, based on average rating. Let me specify that because we are doing average, we are not doing sum, we are doing mean. And it's giving me a color orange. It's told me fixed size 10, 6. You can edit this to 8, 6 is up to you. It's giving me a plotting for the X label and a plotting for the Y label. So I can change this to average rating because I'm doing average, and I'm just going to do the calculation. I'm just going to run it, and look at that. Look at that. So the truth is, the best rated category or the most expensive or the best grossing or the category that is giving us the most revenue is not necessarily the best rated. So the best rated category here is office products. The best rated category is office products, and the best selling category is electronics. That is a point for discussion. The question is why? Why are customers rating the office products more than they are rating the electronics? Electronics comes in there at fifth, toys and games second. So this is somewhere you can generate some, discussion and some business context for. So now that we've done the best rated category, we've done 3 things, is it 3 or 4 things? For exploratory data analysis, we've done basic statistics, we've done the best selling category. We've done the best rated category. And we've also done the most expensive, the top 10 most expensive products. I think we have that somewhere here. We've displayed that. And you can play with it and you can actually do more with this data set. Now, the next thing we are going to do is we are going to, for now, we have completed this analysis. Based on this template, you can also go on to do so many other things, so many other calculations if you want. You can go on to do a lot of other analysis if you want. But the next thing we are going to do now is we are going to export the cleaned data set, and we are going to use that clean data set in the next project for some model prediction. Yes, we are going to go a little bit into machine learning, but we are going to do it using the cleaned data set from this project. So you need to watch out for part 2 of this project where we are going to create some models. Okay. And here, so code. And so in order to export this clean data set, let me just put it here. Or let me change this to text. Let me put this text, explore, export, clean the data set for machine learning purposes. Okay. So what we are going to do now is we are going to export it. So export our data set, cleaned data set. And to do that, we are just going to do df dot to underscore CSV, and we have to specify the path. Sorry, we have to specify the new name, cleaned underscore, let's call this Amazon sales. Yes, Amazon sales dot CSV. Yep, that's it. And you have to put this in quotes because, and then we have to index false. You shouldn't index it. We just need it like that. And you do this. And once you've done this, you will find it here. Where has it gone? It's right here. Look at that there. We have a new clean data set. And what we can do is you can download it to your computer. Remember that whatever is in this environment will only last 12 hours. So download that to your computer, and I will see you in the next video to build some models for this cleaned data set. Now, if you want access to this data set, you can find the data set on our website. Grandeanalytics.com is on the home page. So you just need to scroll down and you'll find it here, data sets for download. And here you have it. It's somewhere here, Amazon sales dataset. So you can just click on the download button and download the dataset from our website, grandeanalytics.com. And yeah, so this is where we draw the curtain for today. If you have any questions, put them in the comments, or if there's anything you want us to work on. But I will see you in the next project, and it's going to be a machine learning project for beginners, of course. And yes, so thank you, and bye-bye. And do not forget to like, subscribe, share, save this video, and let us continue to learn together. Thank you, and see you in the next one.